Hi everyone, we're going to talk about the practice question number 2 from yesterday's classwork. So yesterday we started this classwork. It was called day 1, unit 7, logs, day 1. We started with the do now, we talked about graphing, we talked about the relationship between inverses, the inverses of logs and exponentials, and we started talking about the transformation that can occur on example number 1. We're going to start today on example number 2, which was a Regents question, okay? So first thing I want you to notice the equation that is given to us here. This is called log base 2 x plus 3 minus 5. So first thing is, if you had to identify a parent function of this function, it would be the basic function y equals log base 2, and it would just be x. Okay, so there have been two transformations that have occurred on this equation. And if you ask yourself what they are, the first one is the x plus 3, and that is going to be a translation. Which way? Hopefully you said it is to the left 3 units because the plus actually is the opposite of what you predict. It went to the left 3. And then the minus 5 at the back is going to be down 5. So it is a translation of left 3 and down 5. So if you picture your original log function, which I'm going to show you in the calculator, if you go to the calculator and you go to y equals, and you type in the basic function y equals log base 2x, you would press math up, 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 until you get to letter A, log base, put in base 2x. This is going to be the parent function. If you hit zoom 6, this has got a basic asymptote at the y-axis, or x equals 0, and an x-intercept of 1, 0. But we are going to graph the transformed one. So in Y2, I'm going to show you, we're going to press math up, choose log base, letter A, still put in the same base 2, but within the parentheses, type in x plus 3, and then arrow to the right, and then minus 5 in the back. So this is going to be the transform function, left 3 and down 5. If you hit graph, you'll see indeed it did move left and down. So we're actually looking at this red function here, not the blue one. The blue one's just the original parent function. But notice, I'm hoping you notice that the asymptote got moved. In fact, the asymptote used to be at x equals 0, or the y-axis, but it has moved to the left 3 units. So it's sliding over to x equals negative 3, which I'm hoping you're noticing that. So you can press trace, go down to the red function, and if you scroll to the left, you're going to see that as you go to the left with your x values, we're getting very close to x equals negative 3, and then it kind of disappears. That's where there's the asymptote, okay? So I do want to write down asymptote of the new transform function equation is now x equals negative 3 because it went to the left 3 units because of this shift. The down 5 doesn't make a difference with respect to the asymptote, it just shifts over. So we're going to go to negative 3 and we're going to graph the asymptote. Now, if you go to your directions, it says use an appropriate scale to include both intercepts. So both intercepts means we need the x-intercept and the y-intercept. So before I even graph this, I probably should have read the directions and said, you know what, I need to do a little bit more here. So go to the table. I deleted the other function so we could just notice that we have, we're going to copy down some points, and we know that our y-intercept is 0, negative 3.415. And then the x-intercept, if you hit graph, we don't actually see it. Do you see it's all the way to the right? We have to move our cursor to the right, or we have to make our window move to the right. So let's press window and make your x maximum move to the right, make it like 20, and then hit graph. And again, I don't quite see it, so I'm going to press window again. Maybe I'll make it 50, and then I'm going to hit graph, and then I'm going to see my intercept. So already I know that I cannot count by ones here on the x-axis, because if I count by ones, there's no way 5, 6, 7, 8, 9, 10. There's no way I'm going to hit my intercept because my intercept is way past 10, okay? So that's why it says use an appropriate scale on the axis so that way you have enough increments for you to hit that intercept. Now let's say I don't know what that intercept is. Instead of zooming and scrolling on my table, I can go to y2 or y1 in this case and type in y equals 0. And basically I can intersect my red graph, which is my log, with my x-axis. So to do that, I'm going to hit second trace 5, which is intersection, and then I'm going to intersect them with each other, enter 3 times, and I got 29 comma 0. So that I need to include that my x-intercept is 29 comma 0 and my y-intercept was 0 comma some decimal 0 comma 3 negative 3.415. Okay, so it does say to include a table of values here for some of the other values. So I am going to clear out the 0 so I don't get confused here. And I'm just going to copy down a few nice values that we're going to graph. So I have -2, -5. Maybe I'll just drag it over for the sake of time here. And I'll make it a little smaller for you. Okay, there we go. So basically, I want to graph some of these points, okay? But I can't count by ones because I want to include that 29. So you have to decide what you want to count by. 29, maybe if I made this 30, maybe I want to count by fives. 5, 10, 15, 20, 25, 30. That's too much. Maybe threes. That works. I just hit 30 there, so just keep that in mind. And then the y-intercept, you don't necessarily have to go on the y-axis by the same increment. I wanted to hit -3.41 whatever. So technically I could if you wanted to. You could count by the same amounts, or you could just count by ones on this one. -1, -2, -3, -4, +1, +2, +3, +4, whatever. Okay, so now I'm ready to sketch a few points here, all right? So I'm definitely going to plot 29, 0, which is my x-intercept. I'm also going to graph 0, -3.4, which is my y-intercept. And then I'm just going to kind of graph a few more points as well. Now, please note, I said that the new asymptote was at x equals -3. So I like to sketch that with a dotted line, even though you don't necessarily have to do that. I like to show a boundary value for myself so I know that that value I'm not going to cross. So this is x equals -3, and that's my asymptote. I'm not going to cross over it, all right? It reminds me that it's there. And then I'll just sketch a few more points here. So -2, -5-ish, -2, like that, -1, -4, maybe there. Maybe I'll look at 5, -2. And maybe I'll scroll up a little bit on my table here to get a few more nice points here. Let's see if I can find a nice one. 10, -1.3, meh. 12, -1-ish. 12, -1-ish. Keep going. 13, -1, nice. Maybe one more. 23, -0.3. No, I'm counting by threes. 21, -4.15. All right, let's do that one. All right, so basically now we would connect the dots. Again, we want to try to make it go back to the graph, hit graph. You want to try to make it look like this. So just keep in mind it's kind of growing gradually and it's supposed to cross at 29. Put an arrow on the graph because technically it goes on forever even though the calculator is not capable of showing that. And then when you go over to here, I know that you want to make it stop like this because you see that the calculator makes it stop, but resist the urge because technically you have to approach and run alongside but never quite cross or touch that asymptote. So you do need to put an arrow on the graph here, okay? So here's my equation. I should technically label it log base 2 x plus 3 minus 5. Now, if I scroll down and look at the rest, this part says, describe the behavior, this is like end behavior, as the function approaches, x approaches negative 3, all right? So as x is approaching negative 3, so I'm going to highlight my function here now in yellow. As my graph is approaching the asymptote of x equals negative 3, where's the graph headed? I'm hoping you're saying it's going down. And it is going down toward the negative numbers, which we call negative infinity. So as x approaches negative 3, comma, f of x, which is the graph, approaches going down toward negative infinity. So the English way to think about it is it's heading downward, but toward the negative numbers. And then it says describe the behavior of the given function as x approaches positive infinity. So this means as x approaches to the right, as we're looking to the right toward positive infinity, so you can make a note to self that this means as you're looking to the right, comma, where's the graph going? So let's take a look. As you're looking to the right, I'm going to do this one in green. It's just kind of heading slowly upward, 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 upward. So eventually it's going to positive infinity, but slowly. So you could just say in parentheses up. Okay. So toward the asymptote, it's heading downward to negative infinity. Oh, and then toward the other side, it's heading up to positive infinity. Let me get that back. Okay, so here's I'm just going to circle it. Boom, that's going down. Boom, this one's going up. Those are the end points. Okay, so that's that. And now you're ready to do number 3. So now I want you guys to practice, work together or alone. You could do number 3 and then do all the Regents questions, multiple choice questions. Thank you.